let's say the probability, we'll still use it, the probability Trump will be the president.
A big fat zero?
Well, it could be, but let's say it's 0.35. 35%. Latest poll says Trump has a 35% chance of being a president. Actually, it's about 40% chance of being a president. And they had Hillary 60%. But let's say Trump is a 35% chance of becoming the next U.S. president. Now, if we select this, if we select it, I saw today actually a study was done for Wisconsin to see who's going to win Wisconsin. And they surveyed 400 people. If we select, I forgot the we here, 400 people, and ask them, would you vote for Trump for president? We're assuming these people are random people. The question we'll have a few questions, A, B, C. Find the probability that exactly $130 people will vote for him. 135 or 130, I said. Find the probability of more than 120 will vote for him. And Scott, you said 0, so I'll put your people right here. Find the probability of less than 70 people will vote for him. So these are the questions. Again, I'm going really toward normal approximation to binomial. It is a binomial sample here. Why? To be binomial, there are certain criteria you have to satisfy. One of them, fixed number of trials. And we do have that. So n equals 400. I selected 400 people. Number 2, must be independent. And by using the word random, I'm using that. I like that. Omar said, well, they're Republican, they're not independent, you know? But they must be independent. Yes, it's random. 2 outcomes, or reducible to 2. Well, right now we have more than 2 outcomes for a president. We have Bernie Sanders, we have Hillary Clinton, we got Donald Trump, Kasich, and the whiner, what's his name? Cruz. He always seemed like whining, you know? So we have 5 of them.
It's either Trump or bust.
Yeah. So we got 5 of them, but you can reduce them to 2. Donald Trump or not Donald Trump. So since the question says will vote for him, I'm going to define success as voting for Donald Trump. God, that's why I missed Lewis today. And failure, not Trump. Anyone but Trump. My cat, my dog, anyone, but not him. We don't care. So what's the probability of success here? P. 0.35. What's the probability of failure? Q.
0.65.
0.65. And condition number 4, or criteria number 4 for binomial, the probability of success must remain the same. So yes, 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 and yes. It looks like we did satisfy the conditions for binomial. And the correct way of doing it is really going through binomial, but the problem with that, it says more than 120 people will vote for him. That means I got to find the answer for 121, 122, 123, 124, all the way to where? To 400. Unless you can write a program in Excel or use Minitab or some of these commercial packages, you're not going to do this by hand for 121, 122, 123, all the way to 400 and add them. You'll be there for a few hours, maybe a few days even. So the question is, can I use the normal approximation to binomial? So on the test, you got to decide. It's not only just because of convenient, because I don't want to do this for 100 times. That's not the answer. That's like when you ask people, they want to sell their homes. What do you want to sell your house for? Well, I paid $150 for it when the market was high. I like to get $150. It's not what you want. It's what the market is worth. Your house is only worth $100,000 today. Well, that's the same thing. I don't want to do it because it's too many steps. No, that's not an answer. So can we use the approximation? That's the first question. If I can use the normal approximation, I'll be dancing, because I don't want to calculate all these values. So can we use normal approximation to binomial? And to answer that question, you need to satisfy these two conditions. N times P has to be greater than or equal to 5, and N times Q has to be greater than or equal to 5. If the answer is yes to both of them, then we can use the approximation. So let's see. N is what? 400 times 0.35. What's that, 135? Or 140? That's much bigger than 5. And 400 times Q, which is 0.65, that's what, 260? And that's also much bigger than 5. So yes and yes, yes, we can use the approximation. So now we establish we can use the approximation. Remember, we said this is a binomial event. So if it's binomial, this is step number 1, decide if we can use the approximation. Once we decide yes, we can use the approximation right here, I need to find mu and sigma. What is mu? Mu is equal to N times P. 400 times 0.35, 140, that's the average. And the standard deviation is the square root of N times P times Q. P, which is 0.35, Q, which is 0.65. calculator here.
Square root of 9.5.
91, the square of 91, right? 9.54 roughly. Okay. Now, graph in X, that's what I call it. Graph in X. We're saying the voting is normal distribution. I didn't say Donald Trump is normal, but the voting is normal distribution. It has an average of what? 140. Has a standard deviation of 9.54. And the question is what? The first question. Find the probability of exactly 130 will vote for him. Well, if the question is really 130 voting for him, I don't even have to use this method. I can just calculate that. Right? The 130 is where? Somewhere here. Remember, the 130 starts where? 129.5 and ends where?
130.5?
130.5. We have to make that adjustment of 0.5. This is when we do a plus or minus 0.5 to your value. In this case, we do them both because I'm looking for the 130. 130 starts at 129.5. It goes to 130.5. Now, graph in X, how about graph in Z? Or calculate the Z value. So here we go. We'll try the 130.5. It's 130.5, bless you, minus the mean, x minus mu over sigma, in case you forgot. So 130.5 minus the mean which is what? 140 over 9.5. I carried more than 3 decimal places here. 394 roughly. So 130.5 minus the 140 divided by 9.5394. Unless I'm just looking, I see, because I'm getting a plus, but I have a dead spot, or my calculator shouldn't be a plus. Point what? Negative 0.995. Well, it has to be 2 decimal places, right?
Yeah.
So this will be negative, was that 1? You got around 2 decimal places. You got to add 1 to this. This becomes 0, carry 1, 0, carry 1. And the Z value for the other number, which is 129.5, minus 140 over 9.5394. And this is negative 1.10 when you round to 2 decimal places. Now use the table, the z-score table. Find the area from the z-score table. So we go to the table, we look at the negative 1.00, and what's that number for that, negative 1.00? What's the z-score? I might have actually a z value.
0.1587.
What is it?
0.1587.
0.1587. And let's look at the negative 1.10. And what do we do with the numbers?
Yeah.
Subtract. Let's subtract the two numbers. 7 from 7, 0. 5 from 8, 3. 3 from 5, which is what? 2. 1 from 1, 0. So the probability of exactly 140 people will vote for, is it 140? No. What was it, 120? 120 we said. 130? Yeah. 130 people will vote for Donald Trump. Exactly 130 will be 0.0230 or 2.3%. If this was the only question on that homework assignment, let's say that was a homework assignment and that was the only question that's on it, there is absolutely no reason for you to do it this way for a single value. Why? You know it's binomial because this is an approximation. Why not get the exact answer? The exact answer is what? 400, choose 130 times 0.35 to the 130 power times 0.65 to what power? 400 minus 130 is that what, 270? That's the exact answer. It should be close to that number. 400 math probability NCR 130 times 0.35 to the power of 130 times 0.65 to the power of 270. Yours didn't do it? Mine took a few seconds. 0, 2, 4, 4, 1 roughly. So we're a little bit off. This is the exact value. That's the approximation.
My calculator used to give me overflow.
Yep. The TI 83 is it, or 84?
83.
Yeah, not enough digits on yours. Yeah, the 86 actually did it. Because they're going to do the factorial, bless you. In most calculators, the biggest number you can do factorial on is 69. So if you do 69 factorial on your calculator, it gives you an answer, right? If you try 70 factorial on yours, it says, oh, I can't do it. Mine does it. Why? Because your calculator actually has only 2 digits for that number. Times 10 to the power, they allow you to use 2 digits. Mine can go 3 digits. That's why this one does it. Yeah. But that's also another problem where you want to use the approximation. So if you couldn't do it that way, the approximation becomes a quick way actually to fix that problem. Now the next part here is part B for that question of more than 120.
130. Oh, yeah.
With the chance more than 120 will vote for him. So let's do part B. So question B here, the probability of more than 120 will vote for him. We said this is normal distribution, so we can use the normal distribution. This is the average, which is 140. Standard deviation sigma. Where'd you go, sigma? 9.5394. And it says more than 120. The 120 is somewhere here, and we're talking about to the right of that. Is the 120 included?
No.
So more than 120, what are you going to use for a number? Remember, there's an adjustment of 0.5. 120.5. Because the 120 is not included, and the 120 ends at 120.5. Now we find the z value for that. $120.5 minus 140 divided by 9.5394, and it's negative 2.04. I'm looking to the right. This is the negative 2.04. Well, if I look on the negative value, I'm going to get the area to the left. I can do 1 minus that. Or I can find the positive 2.04 because it's symmetric. This area is the same as that one. So if I look at the 2.04 and look to the left of that, I don't have to do 1 minus that. So I can avoid that instead of 1 minus. There's nothing wrong with 1 minus. I just don't want to do any extra math. So what's the probability more than 120 people will vote for Donald Trump for president out of the 400?
I got 97.88%.
97.9788, which is 97.88%. Now it looks like, wow, he's going to win the election. No, that's just because we expect how many people? The expected value to vote for Donald Trump when you have 400 people based on that percentage is 130. So to get only 120, it's going to be more than 120. 120 or higher. Now the other one is less than 70 people to vote for him. Less than 70 people. Let's look at less than 70 people. Some noises. Oh. One year Jean put a cell phone in the ceiling for April Fool's Day, and she kept calling me in the class, like, where's that cell phone? I can hear it ringing, but everyone goes, I don't have it. But the student knew about it because she was here, and she had it in the ceiling there. So I was wondering, less than 70. 70 is not included here. So the 70 is right here. And I'm looking to the left of that. Since the 70 is not included, so it will be what, 69.5? We are not including the 70. So 69.5. So the z value will be what? 69.5 minus the 140 divided by 9.5394. $69.5 minus 140 divided by 9.5394. That's negative 7.390.
Wow.
And if you look at that chart, it says any number less than negative 3.5, you need to write for an answer what? 0.0001, right? Again, that doesn't mean, well, forget it, he's going to win because there's a 0% chance going to be less than 70 people. Because the average is 30, and we're talking about way to the left of that. So that's 0.01%. Here's what's actually happening. If you were to do a histogram of that, you'll see the 130, it has the highest point, like this. Then start to decrease on both sides of it. It doesn't have to be symmetric, but close to it. Like this. And even more. So you're saying less than this number. That's why the number is small. When you say more than, the average is 130. When we're saying we want 120 or higher, that means all of these. Look at that, almost the entire graph there. That's why for 120 or higher, we got 98% chance. That's all these people. And again, for less than 70, we're talking about the people to the left of this graph. Just a little tiny group there. So your chance here to be less than 70 people voting for him is 0.01%. We expect, the expected value again, expected value for that group is equal to the average, which is 140 people. Was it 140? Yep. To vote for him.
130?
Was it 130? The average, 140. There's so many numbers all over. So we expect 140 people to vote for him. Around that number, the probability is high. As you go away from that number, the probability will shrink. So if I say, what's the probability more than 300 people will vote for him? Probably close to 0. What is the probability of less than 70? Close to 0, because that's far away from the 140. More than 2 or 3 standard deviation. Once you go past 3.5 standard deviation, it's almost a 0 chance.
I have a question.
Yes?
So, when you're trying to find the exact value, you have to use
The binomial.
both numbers on the z-scale, but you don't actually have to use that. You can use the binomial equation.
If you're looking for the exact value, you want to use the binomial.
Right.
The problem with the binomial, you saw that it could be, even for a single value, I just said, oh, that wasn't bad, you'll be crazy to do it. Till some of you inform me, my calculator doesn't do that.
Right.
It's not big enough.
Right.
Then you're going to use the binomial, the normal approximation to binomial. And you have to use, for a single value, I'll go half before and half after, and do it that way. For more than, for example, 140 or 120 to vote for him, there's a lot of values, 280 values to calculate. None of us want to calculate 280 calculations. You know. Even Excel, I still don't want to deal with it, so I'll go in that direction. Or less than 70. From 0 to 69, that's 70 values I got to calculate. I don't want to do 70 values either. I'll use the normal approximation to binomial. How much off are you going to be? Less than 0.5%. In statistics, if you can be within 3% accuracy, we're happy with the result. That's why any of the election, they go plus or minus 3% error. Plus or minus 3. So we're happy to be within 3%. When it's within 1 or 2%, they go that even. Because you're within that margin of error. So if they said like Bernie Sanders versus Hillary in Wisconsin, it's looks like dead even. One could be 51, one could be 49. So that's really, it's hard to call because few people swing from this end to that, it's going to be 50-50.
Above 200 is? What his winning probability is?
What do you mean to win?
Well, if he gets more than